So more complicated case will be useful life bigger than study period. So if useful life of an item or of equipment of an option is bigger than your study period, what you can do? The most common technique is to truncate the useful life at the end of the study period and use an estimate of the market value any equipment used. So this assumes that any remaining equipment or supplies will be sold at market value at the end of the study period. Okay, let's say if your item is good for 8 years, but your study period is only 6 years. Okay, so how do you do that? By this method, it means you truncate at the end of the 6 years, at the end of the study period, and you assume that you will sell this equipment to a market, so you have a salvage value as receiving at the end of the study period. Okay, so you don't have this at all. Okay, so that's the first method. And the primary objective of these various techniques is to compare MEAs over the same period of time, over the same study period. Okay, so all you need to do is to truncate the long useful life of an equipment. And by truncating it, you have to assume that you will sell it at the end of the study period. Okay, and you will add this salvage value in your cash flow diagram so that you can compare all the different options. Okay, don't forget to add this salvage value at the end of the study period. Another thing is useful life of an item could be smaller than study period, right? So the different options for comparing alternatives, when one option has a useful life less than the study period is, you can contract the service or lease the equipment for the remainder of the study period. For example, if your study period is 6 years, but your equipment option useful life is 4 years. Okay, so how do you extend that 4 years to 6 years to compare? You can assume that after 4 years, you're gonna contract the same service to another person, or you can lease the equipment for the remainder of the study period and incorporate these costs into the comparison. Okay, so for example, this is the 0 to the 4 years. So for the equipment, you might pay some dollars at the beginning, and then you have maintenance fees. Okay, and then you're gonna assume that at the end of the 4 years, you need to lease, for example, a new one. So for leasing, you need to pay another amount, and then you can use for another 2 years. And every year you might have, if it's a leasing, then you don't have to pay for the maintenance. The company will pay that, right? So you don't have any cash flow. But you just want to, add this leasing fee on the cash flow diagram. And then you can compare this with another, 6-year useful life options. Another method to handle this situation is you can repeat the course of action for a part of the useful life, and truncate at the end of the study period using an estimated market value at the end of the study period. Which means if you have equipment good for 4 years and your study period is 6 years, okay, so how can you extend the 4 years to 6 years? You can extend it by repeatability method for another cycle. So it's gonna be 8 years. And then you go back to truncate it at the 6 years. And then you sell this equipment at that time to the market. And then you're gonna add that salvage value at the end of the 6 years. Okay, so you extend it for another cycle using the repeatability method, and then you truncate it. The third method is you can reinvest all cash flows starting at the end of the useful life until the end of the study period. Still the same example. So say your item is good for 4 years, your study period is 6 years, okay? So the way we do that, the third method is you have all the cash flows for this item in the 4 years, right? In the useful life. And then you convert all these cash flows to the end of the 4th year. We call it F4. Okay, so that's the future value of all the cash flow at the end of the useful life. And then you reinvest this F4, the value, the total value, into something else. Something else for how long? For 2 years. So that it can be extended to the 6-year study period. And then, because you're going to reinvest it, so you have to know what is the interest rate. So the interest rate for the 2 years is still the MARR. Okay, so that's the third method. The fourth method is to replace the item with a different item, which possibly has different cash flows for the remainder of the study period. So you just, after the 4 years, you just the first equipment retired, and then you just buy a new one. That new equipment could be different than the first one, different price, different cost of maintenance. So it doesn't matter as long as it can last for another 2 years to reach the 6-year study period, it's fine. Okay, so these are so many methods you can deal with this situation. And now the common one is we just use the third option, the third method. And now let's take a look at the same example of that the 4-year and 6-year projects we just solved. Okay, so the same thing. Let's go back to check that example. So here we have two options, A and B, and the useful life is 4 and 6. Okay, and we decide that, okay, let's use the 12 years as a study period so that it's at least a common multiple of 4 and 6. And another method of doing that is, of handling this problem is, okay, so we can just say the study period is 6 years instead of 12 years. Perhaps this is determined by the manager who does not agree with the repeatability assumption, and the manager wants to handle or consider the situation just within 6 years. Okay, so many reasons why we want to use 6 years instead of 12 years. So now the study period is 6 years, and how can we extend the 4-year option A to 6 years. Okay, so we said we want to use the reinvestment method to deal this situation. To deal with this situation, okay? So the reinvest method. So now let's divide this to two parts. So for A, that's more complicated, right? So let's just draw the 4 years timeline. So at the beginning, you pay $3,500, and every year after that, you save annuity as 1255, right? And the way we can extend this 4 year to 6 years is we convert all the cash flows to the future time as F4, okay, FW4. Okay, and then after that, we reinvested this at something else. We don't know, but we know that the interest rate is 10% as the MARR. Okay, so we want to convert this to FW6. Okay, so which means we want to convert the cash flows at the end of the 4th year to a future time at the end of the 6 years. Okay, so the first thing is you need to convert all the cash flow of the 4 years to the FW4. So FW4, don't confuse, this 4 means at the end of the 4th year. It doesn't mean the part 4, okay? So let's just write it as we don't want to confuse ourselves. So we just write it as FW 4th year and FW 6th year, okay? So FW 4th year, we need to convert to the two parts. Part 1 is the 3,500 negative at time 0. So it's to convert a present value to a future value. And FW, the part 2 is the positive annuities for 4 years. So it is to convert A to F, right? So FW 4th year will be the total of FW1 plus FW2. So I'll just write it directly without listing all of them, individually like before, okay? So FW1 is negative 3,500. FW2 is positive. By formula, it's gonna be A times F slash A MARR N. A is 1255. The factor is F slash A, 10%, 4, right? And then this value is gonna be positive 700.105. And now we want to convert this value to the future time at the end of the 6th year. So we want to have FW6 year, which is gonna be, so the FW for the 4th year compared to the 6th year, it's present worth, right, relatively. So the formula is P times F slash P MARR, because we know it is still at the MARR interest rate for the new reinvestment. But the time, it's just 2 years, okay? So the N is 2. So the P is 700.105 times F slash P MARR 2. No, it is 10%. So the final result is 847.12705. Okay, now let's do the option B. That's easy because option B is already 6 years, so you don't have to do any method to extend or truncate. Just draw the timeline. At the beginning, you want to pay 5,000, and after that, every year you have annuities, positive annuities, which is 1480. Okay, so now you want to convert everything to the future so that you can compare the FW6 year with the first option. Okay, so now we'll just use the future worth method. Okay, so you know the FW 6 year consists of FW1, which is from the negative 5,000, okay, at a time 0. So it's to convert P to F. And FW2 is from the positive annuities of 1480 for 6 years. So it's to convert A to a future value. Okay, so FW, the same, 6 at the end of the 6th year is FW1 plus FW2. That's the two parts. So FW1 is negative, and because it's to convert P to the future, so the formula is P times F slash P MARR N, okay, and FW2 is annuity positive, so it's A F slash A MARR N. Okay, so I'll just write it here. So it is negative 5,000 F slash P 10% 6 plus 1480, that's the annuity, times F slash A 10% and 6. So if you check these factors and do the calculation, your final results will be positive 2561. Okay, so the comparison tells you this number is bigger. So the plan B or the option B will be the better one. Okay, because FWB is bigger than FWA, so B is better.